Hey guys, welcome back. This should be the fourth part. So we're going to continue building this DI container using TDD. Last time we added support for reusing instances at the container level, and so we expanded a little bit our Fluent API. In this episode, what we are going to do is first add support for creating container hierarchies, so we'll be able to create a new child container from a parent one, and then we will add some a new reuse scope, which is basically through a container hierarchy. So let's start by adding the test. Basically what we want to do when we create a child container is that registrations that have been done on the parent container can be used on the child container. So that would be something like child, maybe service registered on parent results on child container, right? So this would be, let's create a builder. And I'm going to start using the foo class here because I've been using bar for too long. And foo is more natural maybe, so let's add a new parameterless constructor to foo here so that we can use that. So let's register an ifoo new foo, and what we want to do is get the container that. The action for the test would be to resolve. Okay, first we need to create a child container. Right? And what we want to do is resolve the foo of the child container. And we should be getting okay, so let's first add that method there, and what should happen here? Let's move this up because it's going to be part of the public API. Let's put it up here, and public container. And somebody mentioned that we might want to do the constructor on the container class internal so that it can only be created from the builder. That was mentioned in Twitter. We're going to do that later. So creating a child container. At first we could just do return new container and see what happens, of course. Let's go and run. It would fail, of course, because resolution exception was thrown. Okay, so when we create a child container, basically we need a way to reuse the registrations on the parent container, correct? So we will need to introduce the concept that a container can have a parent. So let's go back to the implementation here, and let's say container parent. Okay, and basically when we create the container here, we will set the parent container as ourselves, or maybe we can even create a internal. Yeah, this would be nicer. Internal container. Okay, now let's do parent container equals parent container, and just so that we don't break the builder, we will need to provide the parameterless constructor too. So back here we can pass ourselves as the parent container and return that. Let's see if everything compiles. Still compiles. Let's run. Of course, nothing changed in the behavior. We are still getting the resolution exception because we are not looking up registrations on the parent. Let's we'll first have to look at the how we're doing the resolve implementation. So let's go back to the container here. Let's go to our resolve implementation and see what we're doing there. So we are getting the service entry, and the service entry, where are we getting it from? Oh, by the way, we don't need this break here because we're doing a return. So getting the service entry, we are getting it from our own list of services. This is where we basically have to try and go up if we do have a parent container, so that we can bring in the registration from the parent one. So let's first do, after we do the try get, we can check if the entry was null and we do have a parent container. Then we should go up to the parent container dot get entry t. Okay, so we go looking up to the parent. Otherwise, we just return the entry, which may be null, and that will be perfectly fine. So let's see how that goes. Pass. That was nice, easy. So what else? We are getting the registration on the parent, and we are getting the instance, and that's all good. So what would be the next test here? Do we know where the instance is being created? So let's add a test that basically verifies what is happening. So instance is created on registration container, and basically what we want to verify here is that if the registration happened on the parent, well, first let's think about the problem. So we made the registration on the parent container. If the parent container did not have the service instance created yet, then it would have that created automatically at that point when we do the resolve here. But we are not doing anything about ownership of instances, so that shouldn't be an issue. Yeah, so let's see how it goes if we use hierarchy scope instance is reused on same container. What we want to say here is that we can introduce, now that we have container hierarchies, we need to add more values to the scope. So far we only had reuse scope at the container level, and we don't have one for the hierarchy. So let's go and add hierarchy here. And now what we want to happen is when we do the register full, we want to reuse that within the hierarchy. So first, we use within the hierarchy container equals build.build, and var child equals container.createChild container. Hierarchy scoped instance is reused on the same container. Okay, so we want to say that it's actually reused within the same container. So basically, that it behaves as the container reuse when we are just within the single a single container. So what we want to do is full1 equals container resolve full, and equals container resolve full, and we should be getting the same instance. on scope because we didn't have any code for that case. So let's go to the container, let's go to the resolve implementation, and let's add the case for the hierarchy scope. So the first thing we want to do there is well, we can, for now we can just copy this because it's going to be pretty much the same except for walking up the hierarchy. So if the entry that we got didn't have an instance, we go get the factory, use the invoker, and initialize the instance and return the instance. Yep, that should work. It works. Now, if the reuse scope for an instance is a hierarchy, then we want to get the same instance also of a child container. Hierarchy scope instance is reused on child container. So we will have very similar to what we had before, but now we have the parent and we have the child container, and this should also be the case, that we get the same instance in the two cases. It passes. Very nice. And I think we are missing another test, which is, in this case we are resolving first. Oh, now of course this passes because we are doing it from the parent the 2 times, not from the child. Oh, it passes. So what happens if we do it the other way around? Will it work? Hierarchy scoped instance is reused on child container. What if we do the resolve the other way around? Hierarchy scoped instance is reused on child container 2. Did pass. So fine, we're good. There's probably something that we will find out later on why we do. I mean, if we do have 2 levels here, container, hierarchy, and container, and we have exactly the same code here, why do we have that at all, right? The scenarios are a bit different. When you have reuse at the container level, you don't want that to. Oh, so what if we specify that the reuse is at the container level, and then we get from a child container? That should fail, I guess. So container, do we have a test for that? Yeah. Container scoped instance is not reused on child. I think we add that when we added the functionality to have child containers. No, when we added the container scope. Anyway, let's do that. Builder. Now, let's just copy this from here, and the reuse scope should be container. And when we create the child, and then we get the full from the parent and from the child, they should not be the same. Okay, and we are getting the same instance, so that's an error. So let's go and see how to fix this. When the reuse scope is the container, then we should get a new instance on the child. And why aren't we getting a new instance? Because when we look up the service entry here, we are basically going up to the parent, and if you remember, well, the service entry is the one that contains the instance. So we are getting the instance from the parent just because we are getting the service entry, which is the registration part. So I would say that what we need to do here is basically detect whether the registration. So we need to know which container this entry belongs to, and if it's not our own container, then we should be cloning the registration on the child container, and we can do that on demand, so that we don't impose a performance on copying every time we create a child container. So so what we might need to do is first, the service entry needs to know which is the container it's being registered on. So we'll have a container where the entry was registered on, and who needs to set up that property? Probably the container builder. At the time it's building the container. So basically when we build the entry here, we should say that the container for the registration was the container we are creating. And what else? And here in the container, when we get the service entry, if the reuse scope is container, the first thing we should check is whether the container is the same as ours. So let's see, we could do, if first of all, right, we should check if the entry dot container is not ourself. Here we should do something. Let's define a variable here, entry for the container entry, because it may be the one that we get up there or not. Container entry. So if the container is not the same as ourselves, so we should basically create a new entry and register it within our own container. So we should do, here we should clone the entry, but set the container to ourselves, and then we should say register for the same key that we got, but for the new container entry. Right? So let's add this clone here to the service entry. Should be something like service entry clone for a given container, and we can return a new service entry. Basically copy the everything. Reuse, I'm sorry, scope, and what else? Container, new container. And we are not copying over the object instance, because the one that takes care of creating the instance is the container, not the entry. So we'll just copy the entry values. So the entry clone for this, and we register, and that's all. Now from that point on, we would basically have to, well, if it is not, so if it is the same as ourselves, then we should just say that the container entry is the entry. Now we can make this change here. If the container entry instance is different to null, then we go and create the instance. This might be a good, okay, this should be container entry, container entry, container entry. And we have these couple lines of code here, duplicated here and there. So maybe we can go ahead and refactor that, or maybe we can do that later. So if the container instance is null, then we go and create a new instance. We set the entry, the container entry, and then we return the instance. Good. So what we did is we refactored, we added more behavior here for the container. We added the container as a property on the service entry so that we know which container the entry has been registered with. And let's see if that makes the test pass. Cool. Great. Passes. What else is missing here? When we're doing hierarchies, let's see. Hierarchy scope instance is reused on child container. Do they all pass? Because we made some changes, so we should run all of them. Yep. So recap. We added the functionality of creating child containers. We added a new reuse scope hierarchy, and we made sure that the container reuse scope works as it was supposed to. Apparently, we had a bug from the previous screencast, and we added a new test that basically reproduced that, and we fixed that. The service entry now knows where it's being registered, and we are not cloning all of the entries when we create a child container over here, so that we don't. So that basically creating a child container is a cheap operation. So stay tuned, and on the next one we'll add ownership of the instances, so that when you dispose the parent container, you get all the child instances disposed across the hierarchy.